engineer here at Hootsuite. I love DevOps, I love Docker, and I'm also a hammer. And probably like a lot of you recently who've kind of been interested in Docker, you've been kind of looking for a nail to pound in with it. So looking for something to apply Docker with that solves a problem that that we can learn a lot from before it kind of moves to that version 1.0. It's safe for production version, which I'm really curious who that's going to be. It's probably going to be some blog posts from some large companies saying, hey, we just pushed it to production, we're running this thing, and everyone gets excited. There's going to be a tidal wave of people that'll probably move on to that. So we have some unit test problems, and like a lot of you guys, it's probably really familiar. Monolithic code base, extremely complex setup. We have PHP, a million extensions. We've got 0MQ, Gearman, database connectors, the whole bit of it. And when we started out, what, 5 or 6 years ago, we didn't really unit test as we developed. So unit test kind of came in afterwards, filling in a lot of our code coverage. So because of that, our models and base classes weren't properly mocked out. As a result of that, the test hit databases a lot. So we have MySQL as our main store, Mongo, Redis, and we were looking at replacing Mongo with Postgres and Couchbase and the rest of that. So a lot of these tests, when we run them locally on the network, would go over to a shared development MySQL server, run that test hitting a network hop every time. So it was quite painful and very slow. Also, we had some issues with Jenkins. We use Ansible and love Ansible, and so setting up and configuring production and staging is a manual process. When we update Ansible, we have to manually go image a machine on EC2 and roll it out. And Jenkins was the last of it. So when we upgraded to PHP 5.5, it took months to actually be able to use it. So even though it was running on production and it was running on local dev boxes, people would push code and they would use newer syntax or newer features, it would break the build because the test couldn't run the code. So it was the last thing down the line that was holding us back from fully going and upgrading. So that was the nail. Found the nail. Okay, here's something that I can use Docker. It's a good experiment, and we can parallelize the tests. So it solves a real problem, and it's relatively low risk. It's not completely devoid of risk because the build pipeline and unit testing are integral to our process. But unit tests and the build pipeline generally runs during the day when we're here at work. So if it goes down, at least we're here and we can solve it. So it was on the lower end of risk, and it solves a problem that would be used quite heavily. So the plan was to fork out the tests onto multiple Jenkins slaves. So at the time, we were just running one master Jenkins server. And the idea was to then create several, 10 or more slaves, and then run the tests on Docker on those slaves. And with the goal being that the only dependency would be Docker and Git. Keeps the slaves really lean and very simple. So this is kind of the general layout of what we set up. So there was when you commit, when you push, there's the unit test script that checks out the code, kicks off 2 containers. The first container has all of the runtime, so PHP, Phantom, Casper, PHP unit, all the stuff you need to run. And it would talk to another database container, which was linked, and that ran MySQL, Mongo, Redis, and cached all that stuff. Those were pulled from a private Docker registry, which was set up on EC2. That was backed with S3 and Redis cached, and sat in front of HTTPS, so there was HTOF kind of protecting our code. So brought down the test roughly to about 25 minutes running on one machine to about 3 minutes. And it could be lower depending on how many you want to divide the tests up. And so it was a clear win, but there was quite a lot of issues that I discovered kind of, along the path to setting this up. So here's some of the findings. Configuration management. So as I was saying, we use Ansible. And it was a question of how to integrate Ansible into a container. So we don't want to put everything into a Docker file, although that's a really great option if you're starting out and you want to create a small container, you're distributing an open source project. But we need to integrate Ansible. There's no question on that. So I first tried out setting up a SSH daemon inside of the container, spin up the container, and then Ansible would provision through that connection. But to me, it just seemed kind of the wrong direction, and it added 40 megs of fluff onto the system. So later, I changed directions and I tried installing Ansible inside of the container. And I guess if you're using Puppet or Chef, it's probably the solution you need to go with. There's probably some other ways around that. You might be able to extract a container, mount it, chroot, run Ansible onto that chroot, and then import that into the container. But I think with that, you would also lose one of the really nice features of Docker, which is layering, is that any layers below, in a container that you're pulling that you already have cached on your system, you don't have to re-download that stuff. You just download the top layer. And I think that if you use that approach, you might break the layering. It just becomes one big fat container, and so that might not work. There's another project called Packer. Packer is a tool for creating machine images, whether that be for VirtualBox or Vagrant machines or Amazon AMIs. But it wasn't quite there yet, and there wasn't a clear way of provisioning a container from a starting point, a base container, adding some stuff, recommitting it as a new container. I think that's changed now. I'm not sure, but I'm kind of hoping that this project evolves.
I picked them up about that.
Yeah.
From the base marble.
Yeah.
Work on it.
Okay.
Right.
Yeah, because this would be a great solution because Packer plugs in with Chef, Puppet, Ansible, all the different provisioners. What's nice is that also has a whole bunch of outputs. So we've got, like I was saying, Amazon AMI, so you can output, put that or a Docker container. So you're not, it's kind of the linking bridge between all those options. But it's also rumored to be integrated into Docker itself. So I kind of consider that to be like a soon to be fixed issue. So the question is, why not just like provision the Jenkins slaves directly? But with this, you have continuous integration, updating the continuous integration, which is really nice. If you're just updating, and I guess it'd be hard for the slaves to re-slave themselves. Anyways, when you run the unit test, it does a Docker pull, Docker run. And if those images, those same hash IDs are the same, it is just going to run the test and spin up those Docker containers like within a second or two. So it's super fast. So if you make a change, it's going to grab that the next time you run the test. It's also really easy to scale. If we needed 10 more, 20 more slaves, we could easily just spin up a machine, and it's super easy to set up a Jenkins slave. Really, all you need to do is set up an SSH connection, connect that with the master. The master will SSH to it, install a jar to get the slave running, and that's it. So beside that, you would just need Docker, and it would be extremely easy just to add slaves. And it was also part of the experiment that I was trying to run here. So there's I guess what we call like a PID1 problem. So when you launch a container, that first process effectively inside of that namespace acts as process ID 1. And there's some kind of quirks with it. One of them is that you can't kill 9 it, like you can't say kill it, because the kernel says, hey, you're PID1, you're not supposed to yank me out of memory, go ask me let me handle that process. And most processes actually don't handle that well.
You can sort of do that though with LXC kill or Docker kill.
Yeah, I think you can kill the container itself higher up, right?
Well, you're killing the root process inside of the container, but you
Yes, yes. And then also, if you're running more than one process, say for instance the database container that I created, I had all those other sort of Daemon-ized processes, Memcache and Mongo. If one of them went down, I wanted them to be watched and respun. For unit tests, it's not that important, but if you're running something a bit more, mission critical, that would be, kind of required. So we tried out Supervisor D. It seems to be what a lot of people use to solve that problem. So the entry point of your container is Supervisor D, and then it has the child processes underneath that it watches. So it worked well.
Are you saying system D on the outside or the inside?
Supervisor D on the inside. Yeah, but the integration is coming for System D and like old school init systems. So I know that's kind of on the roadmap. That's maybe some of your comments on that. And I think that's actually one of the major problems right now with Docker and containers. You can work around it, but it just doesn't feel...
Traditional System 5 and works fine. OpenRC works fine. It's just upstart and System D that are...
Right, I'm running on Ubuntu, so like trying to get... I basically did a few things to just get Upstart to shut up.
No caution, if you try to run the System D inside, you can really screw up your host system as well, so don't try that.
Yeah.
Yes.
So this is the new thing, just in version 09. So it's kind of replacing LXC. LXC, I guess, is a grouping of namespacing implementations. libcontainer is a pure Go implementation that talks to those namespacing directly. I don't know too much about it, so I can't talk too much. But it allows you to, there's a nice tool in there. I haven't got it working on myself, but which is NSInit. It allows you to attach a process into an existing running container. So if you have a running container, like say my database container, and I want to see what was going on in there, I would be able to attach like bash to it and then be able to navigate within that process. So I think it's a kind of critical feature for kind of long-running containers that you're able to actually go inside of it and inspect it. But you're still able to run Docker with LXC. It's still a viable option, and you can use LXC attached to launch bash inside of your container, and away you go. So I set up a private registry in the cloud, and it's really slow to work locally and to register in the cloud because the containers tend to get really big. We've been developing for years with the idea that you install all of what you need, you throw the kitchen sink at a virtual machine or a server, and then you put your code on top. So we haven't really been paying too much attention as to like the size of what gets installed on the machine, because that hasn't mattered. But now that you've got everything wrapped inside the container, that size becomes really important. So I was getting, at first run, I was getting 2 gigabyte containers, and then trying to work locally and push back and forth 2 gigabytes is kind of painful. So I was thinking, okay, well, we can set up a local mirror. And then actually, as I was writing up this presentation, I had a look again, and it seems there was a commit somewhere in May, February that they allow you to do a Docker registry. You can set it up to mirror an existing registry. So working locally in between the cloud can really, that to me seems like it might be solved.
Got a happy level 5. So if the registry is too slow for you, revert back to tarballs and rsync in place. Much faster.
So yeah, I mean, with the registry, you get a nice, consistent like API that Docker interacts with. With tarballs, I guess you're just kind of copying files back and forth, right?
Yeah, you can do it. It's rsync -- in place, which will only copy the bytes and change in tarball.
Right.
So it's faster than doing container slices.
There we go. Solved.
All you need is bash.
Yeah.
Pull request. No, we don't take that.
So, like I was saying, the containers can get gigantic. And installing a package installs a whole bunch of garbage on the system. And I gotta say the worst offenders of this are Apache projects. Like as an example, just installing PHP from say like apt-get, it has a recommended package of Apache. And then Apache installs a bunch of other stuff. And all you wanted maybe was just PHP to run on the command line. And normally on a server, you didn't care. You would throw a couple hundred megs on a server, and it wouldn't matter. But it's amazing as to what you can see in there. And that's one really nice way of figuring out what's going on with a package is just get a raw base Ubuntu box or CentOS or whatever, install a package, and then do a diff on that layer, and you get to see exactly what's been done with that package. It's a really great way of seeing what these package maintainers are doing. I found a couple of good tips for kind of trimming out the fat. One is filtering out all the man and doc and info pages, because you're not really going to need that inside of the container. I mean, you can go Google man, like Google is your man page now. I'm really curious, like who uses man pages? Now, who uses info pages? Why do we have both of them? I don't know. Is this like, it's a GNU thing, right? Yeah. So another thing is the app cache. So when you do like an app update, it'll put a whole bunch of information in var caches, whatever.
Another hack one might want to do with the app cache is make it so it's a volume and then host bind it, or not bind it to the host.
Oh, right.
Your installs share the app cache, even if they're not.
If they're in the same OS, right?
Yeah, they're in apps, both in the same OS.
So yeah, I was surprised of how much stuff gets cached away in that folder. And then if you really want to slim things down, you can always export a container and then re-import it as a fresh kind of flattened image. And that's what I did on the base container. The first thing I did was do an apt-get, and an apt-get will pretty much go in, or sorry, an apt-get update or upgrade will touch so many files on that file system that your layer above that is almost entirely new anyways.
The alternate way of doing that as well is you can do just make one run command on the Docker file. Just make it one run command. It'll just all go into one layer.
Yeah.
That's another way to do Docker export import as well.
Right. So I had some trouble kind of figuring out exactly how I wanted to layer my application. So I start off with Ubuntu 12.04. I put the base on there, which was Ansible and a couple of tweaks like filtering of man pages and all that stuff. Then I would put like all of our runtime, like it would be Nginx, FPM, PHP, all the other stuff in there. And that was where the most, like the majority of the meat was. That ended up being about 650 megs after I kind of worked it down for from 1.5 gigs. And that's kind of this whole container here. That's sort of what I want as the shippable unit that you then kind of move to staging, to production, to everywhere. But to validate that container, to actually make sure that you know that that container is good, you want to run the unit test. But then you got to put the unit test dependencies. So you have Phantom, Casper, NPM modules, you got PHP unit, you got all this junk on top of there. And that was surprising to me. It was an extra 400 megs of stuff. But I didn't want that in the container. I wanted that stuff to be run once in the container, validated, and chuck it away. So I still haven't kind of figured out a good way of doing this. And this might be something in the future. If there's a way of injecting a layer somewhere in the middle of like the containers, I don't know.
One thing you could there, you can do volume small. So you have a data container which contains your argument. It's not going to change very much. And leave it by itself. And then when you're spinning up the new ones for your specific tests, mount them from there using the dash volumes, or actually Docker single dash.
Like mount the dependencies.
Yeah, from another image.
Yeah. I think that'll work for like NPM packages. Some of the stuff being where it's kind of like hooking directly into like Etsy or the rest of your PHP modules. It's a bit trickier. But yeah, I mean, another option is that you create one container here and then a second container where it has the unit test dependencies, and then you stack the code on each of those. You test with one, throw it away, and then it validates the other container. But then again, you're sort of moving away from this idea of this immutable server install, and it seems kind of, I still haven't figured it out.
Can you just have like whatever you have in that gray rectangle, have an image, add the unit test, make sure they're working, and then ship whatever that's in the gray box?
Yeah, so you can't do that, but then adding all that stuff on top of there, because there's quite a lot of defenses we have, again, that's running with Ansible, takes quite a long time. So every time that you want a unit test, you then have to provision on top of that. So it brings the runtime of unit test kind of way back down. So
I'm a little confused why Ubuntu is in your container. Wouldn't it be like the host OS? Shouldn't there be no OS inside the container?
Well, so you start from like a base image, like a raw OS install, whether that's Ubuntu, CentOS, and I pulled that directly from the public Docker registry, and then started from there.
But if you have an OS in your Docker image,
This is the file system. So it's not the running system of the host OS. It's the file system that you need to be able to use inside the guest.
Anything that's supported by the Linux kernel can be used. It's just a base file system state that's sort of a firewall. And
Right.
it just uses the host.
So when you run a container, you have to think about it like all the system really sees is like this container, and then there's the kernel, and this stuff is just kind of attached to the kernel. So
it's not like a full Ubuntu, it's just kind of like an interface.
it's actually the whole Ubuntu, like a really trimmed down. Like if you were to do an ISO install on a machine and then just tar the whole file system, that's essentially what you would get there.
I just don't see how it's much different than like an emulator running like a native extension.
Well, it's all the file systems, all the system calls you're doing runtime to an emulator or a virtual machine. You're having to virtualize those, and there's a performance overhead. But with this here, your file system contains just the files you need, and then the kernel operations you're dealing with are in which kernel directly, just in the namespaces.
But with virtualization extensions, there's very little overhead. I guess this is none versus very
This is
little.
almost none.
This is almost done. You don't have machine translate. Also, the scheduler and the kernel, you're going to be dealing with all your caches, L1, L2, 3. Like all those kind of get destroyed when you've got multiple VMs and a hypervisor. So you get a major performance boost because it's just one kernel, one machine, scheduling and being smart about how it can kind of juggle the processes.
And also, if you're trying to figure out what else going on with my performance issue, having one scheduler is a blessing.
So another thing that I found was linking containers is kind of cumbersome. When you link containers, it injects into containers you're linking with environment variables. So this is just like a sampling of some of the environment variables that get passed in. So if I'm trying to pass in the MySQL connection details, you need to then in your code grab those environment variables, inject them wherever. It works, I just find it very kind of cumbersome. And if you're linking multiple containers amongst themselves, they recommend having an ambassador container. So it's one container that essentially links several other containers to pass stuff along. Personally, I find that kind of a bit odd. It's a bit weird. So, there's kind of talk of service discovery within containers, but that might be out of the scope of what you're actually trying to ship. So that can work as a kind of solution for your project or your company wide. But I think as a container you're trying to ship it, it's a bit weird. And I think that there's some rumors that there's something in the pipeline.
There's something for that. Well.
Yeah.
Michael Crosby Michael, I don't know which way his name goes. He's one of the board members, and he came up with something called SkyDoc, which is a Docker integrated version of SkyDNS. It's SRD records, your DNS for service discovery, which gets around the issue of the link pattern there being fundamentally insane. Minor rant, but go ahead.
And I found there's a bit of unknown maintenance profile. So there's a few Linux tools that are not really ready for namespacing yet. Kind of the two main ones are free and top. They show the overall system memory usage, but not how much has been allocated inside the container. And so far that hasn't been an issue, because I haven't been limiting any of the containers. But if you're running more of a platform as a service type system and you've got 20 containers on one machine, it's going to be a real issue, especially for apps that would be trying to allocate memory that might go out of bounds. So it's a bit of actually a problem within the kind of Linux namespace in itself. So logs as well is a bit of an unknown. If you're running Nginx and it's outputting logs to say var log Nginx whatever, should that be inside of the container, or should you have logs going outside of the container on a mounted volume? And I'm kind of split on that. You know, there's performance of AUFS, and as Matt was saying, is that that's now pluggable. So I think there's ZFS and WaterFS and some other options that are there. But should that be inside the container? One advantage of that is maybe if you've got a problem on production, you can snapshot that container, pull it locally, inspect it, and actually, kind of bring it into the shop and play around with it.
There's another issue with logs as well.
syslog as well.
Yeah, syslog and kernel log are not namespaced. So you see the stuff the most.
Yeah, so it's a bit of another sort of like gotcha there.
One thing that Dennis has been doing is that we throw it in our syslog and just pipe them off to another container. So that's another way of doing it.
Like link the container and get syslog to
it gets syslog through etcd. Like we'll have an endpoint that's a Docker container that's published on etcd, and basically the container will look for that endpoint on there, and I'll just pipe the logs off there.
Right. It's interesting. So one thing that I really like about the design of Docker is its API first design. So Docker gets stabilized, and from there on, sub-processes are, containers are sub-processed from there. The way that the bash communicates mostly with the Docker is via REST API. And I don't know, I just found that to be a really beautiful kind of design. It allows for a lot of kind of open integration. I think Shipyard and a few other projects are leveraging that to control containers on remote machines. But yeah. And I found this great for open sourcing. So I was hoping to have it ready for today, but we're still going through legal. But I was going to open source a small developer tool that I made a year ago. It's for when people figuring out their machines. It creates, there's an API, a very simple, unauthenticated API that creates a DNS record. It allows you to see who is in your network and see the domains. Also allows you to do SSL certificates on your bigger machines. So I thought, okay, great for open sourcing. So to distribute this, we create well, I can create a Docker file, package all the code in there. So anyone that actually wants to run it, it's fantastic. We just Docker run, it pulls it from the public registry, 0 install. We just set a config and away you go. And for standalone little web apps, I think